Hello, and we return with a concept question. I'll do another calculation in a future video just to give you another example of that. But here we're looking at two trajectories. And one thing that I think is probably not super clear from the drawing, there's a little bit of an optical illusion going on, is that these two vertical heights, the maximum height that they achieve, so right there, okay, is meant to be drawn so that they're exactly the same, okay? So we know that, and we know the trajectories have these shapes where the red one here is going a lot farther in the horizontal direction. But otherwise, we're not really given any information about this situation, and we're asked the following questions. I suppose I should have not a question, but questions, okay? Or maybe not even questions. Look at this. Periods on the end of these. Anyway, compare the projectile's initial vertical velocities. Okay. Well, what can we say there? Well, let's think about it this way. All right. They both reach the same maximum height. And if we look at this equation of motion, this one right here, for the vertical motion of a projectile, let's see what we got. So if we're talking about going to the very tippy top of the trajectory for each one of them, we're not making any judgments about how long it takes them to get there or anything like that. We're just looking at the very top. So here for that one, here for that one, and that we should know at this point means that for an instant, their final y velocity, right? If we're looking at that being the final point at the top, that's going to be equal to 0. All right, so that doesn't come into it. And here's our initial vertical velocity that we're trying to answer a question about, or, well, compare one to the other. And if we look at the rest of the factors in this equation, well, then we've got acceleration, which is the same. It's just downward in g for both of them, whether or not you're talking about the short trajectory or the long one. And delta y, right? So the displacement going from down here where they start to up there at the top, well, that's the same as well. Again, we're only looking at the vertical part of the motion, so we don't care really that this one happens farther away horizontally than the other one, okay? We're treating these independently, and you can do that with projectiles. So what does this equation now tell us? Well, the left-hand side is the same, right? This is the same for both of them. Every other factor in this equation is the same for both of them. And so the initial vertical component to their velocities must also be the same, okay? That is a counterintuitive thing, typically, for people, but it comes straight out of the math. And that's how you do the comparison, all right? Really trying to drive home the idea that you can decouple the vertical motion of these projectiles from their horizontal motion, all right? So the comparison here is that they are the same, okay? My toddler is doing some letter identification out there. They are the same. Okay. Number 2, compare their initial horizontal velocities. Okay, well, this one I think is definitely more intuitive than the previous one, right? If this one's going to carry this one right here, right? The red trajectory. This one's going to carry that far, okay? Well, then it makes sense that the initial horizontal velocity of that projectile is going to be greater than the blue trajectory, right? I think that does make sense. Most people would say that that does. If I go and grab a different color here for a moment, do red. You can also sort of look at the velocity vectors that must have produced this. Remember that we just said that the initial vertical velocities have to be the same. So if I draw the initial velocity of the red and then I draw the initial velocity of the blue, then I have to draw them so that their vertical components are the same, right? If you drop down a little line here and drop down a little line there, they're the same. I think I've drawn that pretty well. And so the horizontal component, right, this big for that one, and bring back my color chooser, and it would be this big approximately for the red trajectory's initial horizontal velocity is quite a mismatch, right? So we'll come back to that one as well. Now, for comparing their initial speeds, the magnitudes of their velocities, well, if their vertical components are equal, but their horizontal components are different, and the red's horizontal component is larger than the blue's horizontal component, well, then the speed, the magnitude of the red trajectory's initial velocity must be bigger. So red is bigger. That means that red is bigger here. And then lastly, weird. Okay. Compare their times of flight. So how long they're in the air. Okay. And this is another intuitive one. Most people, when they look at this kind of thing, particularly if they're asked this question or asked to do that comparison first, they almost invariably say that the one that has a longer path, so the red one here, is going to stay in the air longer. But as it turns out, and if you've been thinking about our conclusions for 1, 2, and 3 a little bit, you might have come to this conclusion as well. As it turns out, the time of flight for both of these trajectories is exactly the same. Okay? So this, you can make a number of different arguments here. Okay? One, and this is a hand-wavy one, is that if you just concentrate on their vertical motion, they start with the same, and they start the same way, they go up to the same point, and they return to the same point. Right? They both achieve the same maximum height. They both start from and return to the same vertical position. And if you just concentrate on the vertical motion, which you can do, right? Those two things are completely independent for projectiles, then there's no difference between them. And so you would expect the time that they spend in the air to be exactly the same, like a ball that you threw straight up twice to the exact same height. You would expect to get the same time of flight for both of those things. Okay. Now, more formally, if we take this result, right, this argument that we made for number 1, where we concluded that their initial vertical velocities have to be the same according to that equation of motion, well, we can break out another equation of motion to tell us that their times of flight also have to be the same. And that equation of motion, well, you can use more than one, but that equation of motion that I'm going to use is this one. Okay. Now, from number 1, we determined that this is the same. Again, if we're going up to the top of the trajectory, this is also the same. Okay. And this, by definition, because they're a projectile, also the same, right? Just equal to g and downwards at that vertical acceleration. And so if every other factor except for time is the same for the red trajectory and the blue trajectory, well then the time must be the same. Okay? So those are some classic conceptual projectile motion questions. You will undoubtedly see some variations on those things as we move through the class and as you work on your assignment this week and moving into the exam and future quizzes and things like that, okay? So if this is clicking, great. If it's not, please, please, please drop into a discussion forum or into my office hours or something and let's talk about it. But I hope the logic that I've presented here is like crystal. So, on to the next one.